Well, I don't know, honey. That car's been parked there for a long time. Well, no, of course I didn't. I had Cinco de Mayo at the Jeffersons. Whoa, that's a mean-looking tennis player. Tennis player. Tennis player. Tennis player. Tennis player. Tennis player.
That was the song Squash Man by the squash-themed hardcore band The Eradicator. And today I'm here to talk about color in CSS. And the reason why I picked this topic is that recently, about a year ago, I got really excited about color in CSS. And I shared my excitement on social media. I wrote, "It surprises me how excited I am by color theory. I find it hard to understand and learn, but super interesting. I can see myself digging into colors on the web next year." And to be honest, I never really cared a lot about color in general and also color in CSS. But I was working on a new workshop with my friends at Smashing Magazine called the Advanced Modern CSS Masterclass, where I teach people all the new cool things in CSS. And in preparation for this workshop, I made a list of all the new properties, modules, and also just terms that I wanted to teach. And looking at the list, you see that there are many things that people are really or were really excited about, like container queries or nesting, or my beloved has pseudo class, and I don't know, stuff like light, dark, and gamuts, and so on. So a lot of stuff. And looking at the list, I realized that many of these items are not just new modules in CSS, but also related to color in CSS. Quite a lot of them, actually. And these are only the recent additions, and that made me curious. Like, I was wondering how much is there we can actually do in CSS, because like I said, I didn't really care a lot about color in CSS. So I went back 5 years, 10 years, even 20 years and more, and I realized there's a lot, and this list is not extensive. Like, there's so much more we can do in CSS. And, you know, obviously CSS is evolving and constantly growing, and in 20 years stuff happens, right? But when I had this list in front of me, I was surprised by how much there actually is and how little I was using for the most part of my career, I would say. So my goal today is to get you as excited about color in CSS as I am, and I want to introduce you to some of that cool new stuff and show you how to use it in your projects today. And to do that, we have to go back 25 years when I built my first website. Don't worry, I'm not going to take you down memory lane for the next 15 minutes, but we have to start very early. Well, we have to start actually at my very first website. What you see here on screen is a snippet I took from my first website, or one of my first websites. You see the body, start, and end tag. And you can see that I'm using color here. And I'm using presentational attributes that don't exist anymore, like the BG color attribute, the text attribute, and the a-link attribute. And what I'm doing here is I'm styling the background color and the text color and the link color without CSS, because at that time, that was like in the late 90s or early 2000s, I CSS was around, but I didn't know CSS, and all I could do is, style my page using HTML, and it was fine. So the reason why I'm showing you this is that I'm using hex codes here, which isn't too special. But when I got started with web development back then, I was told that I could only use a tiny subset of the 16.7 million colors that sRGB offered, the so-called web safe colors. And that's because most screens in the 90s could only display 256 colors. So we were limited to those colors that you see on the screen right now. So if you wanted to use colors, you had to pick from these 216. So it's not 256, it's only 216 because some of the colors were reserved for the operating system. And there was also another practical reason that doesn't matter right now. So the thing is, we were very limited in the amount of colors that we had. So in theory, there were 16.7 million, but we could only use 216. A couple of years later, like I think in 2006 or so, I learned CSS finally, and I was actually, doing the same thing, using hex values. But now, of course, I had more colors at my disposal because the screens eventually got better and could display more colors, and I wasn't using presentational attributes anymore, but CSS. So that was a big milestone, like this switch from HTML to CSS. And another big milestone in my early days that was related to color was gradients in CSS. Because before we had gradient functions, in order to create a gradient, you would start an application like Photoshop, draw a gradient, change the canvas size to 1 pixel, save it as an image. Then you would go into your CSS, define a background image, use that 1 pixel image, and repeat it on the x-axis, and that gave you a gradient. And then you had to do some tweaking, to fill the entire screen. And nice gradient. Works pretty cool. And I absolutely love that technique, and I still love it. And we also used a similar technique to create box shadows before we had the box shadow property. Anyways, that's how we did gradients. So that was so when we finally could do it with CSS in CSS directly and dynamically, not using an application like Photoshop, that was a huge thing for me. And that was it, at least for me. I don't know, like for the first 15 years since I started or something like that, I didn't do much more with color. Background color, define a hex value. Color, define a hex value. Maybe border color, and then, at some point I was using gradients, but that's about it. The only other thing that I was using or doing is instead of using hex values, I would sometimes use the RGB function, or actually the RGBA function, because the nice thing about the RGBA function is that you can also provide an alpha value for transparency. That was really convenient. But the thing is, I never really understood how the RGB or RGBA function is better than hex, because I find both essentially unreadable. Like both are very, very developer unfriendly. So if you look at this hex code, for example, can you tell which color it represents? Like, can you just look at the letters and numbers and tell me which color it is? Probably not. Like, at least I can't. It's the color you see, like the color, the font color here, this dark pink, whatever that is. And if I show the same color in RGB, does it work better? Probably not. I mean, you can guess the numbers make it maybe a little bit easier because, there's a lot of red and not so much green. But in the end, like, at least I can't read it. But actually, there are people who can read hex. I was in Hamburg last year for the Hamburg HTML meetup, and there my friend Marco, who's also here today, told me that there is a talk by a colorblind designer named David DeSandro, who explains how they can read hex and tell which color a given code represents without necessarily being able to perceive the color. And the talk is on YouTube. It's called Read Color Hex Codes by David DeSandro at .css in 2018. So really interesting. I didn't watch the whole thing, but I skipped through it. It's pretty interesting how it breaks down, how it reads, how they read hex codes. Anyways, so hex codes, okay, but not really developer friendly. What I like much better than hex is HSL, because HSL is actually developer friendly. The HSL function takes 3 values: the hue, represented through a number or an angle starting at 0 degrees and ending at 360 degrees. Then you have the saturation, which defines how saturated the color is, so how intense, how vivid it is. You go from 0% to 100%. And then we have the lightness, which defines how light or dark it is, starting at 0%, which is black essentially, and going to 100%, which is white. And if you know how the color wheel looks like, where you define the hue, so the color, then it's really easy to read HSL. All you need to know is that it starts at 0 degrees with red, then it turns yellow at around 60%, then it turns green at around 120, and so on. Then it gets light blue or cyan, and then blue, magenta, and then red again. And if you remember that, then it's pretty easy to tell what a color will look like. So if you look at this code here, we can tell that 120 degrees is green. 100% saturation means that it's a really strong, intense color, and 10% lightness means it's a really dark color. So an intense dark green. Cool, much better than hex. Here's a representation of HSL. You see this cylindric shape, and in the circle we pick the hue. Going from the inside out, we pick the saturation, and going up and down, we define the lightness. This is how HSL works. And HSL is especially great when we work with custom properties. So what you see here is an example of a very simple notification component, or in other words, a div. And I use it to inform people about stuff that's happening on the website. So you see here is an info component, and it has a light blue background and a dark blue border. And for the background color and the border, I created a custom property, and I'm using it with the background color and border properties. And if you look closely at the HSL functions, you see that both the background color and the border color share the same hue, the same saturation, and only the lightness is different. So you can see the border color has 20% less lightness, so it's 20% darker. That's fine, but we can optimize this code so we can create even more custom properties. I'm a huge fan of custom properties. So we create one for the hue, one for saturation, and for lightness. We reuse the hue, we reuse the saturation, and we define the lightness for the background color. And in the border color, we use the calc function and subtract 20% from the lightness. Much cleaner, and that actually looks really cool. And what's especially awesome about that is if we wanted to create variations of this component, then all we have to do is duplicate it and change the hue custom properties. You can see I'm using the style attribute here, and I'm setting the H custom property to 40 degrees and 0 degrees. And this gives me a variation of the same component with different colors. And that's really cool, because HSL is perfect for color systems in design systems. Except that it isn't, because there's a problem with HSL. It's kind of like tennis. So it has some great features, but it kind of sucks. And before I can explain why, we have to learn 2 new terms. The first term is gamut, and the second term is color space. And I guess now is a good time to tell you that I'm not an expert in color theory. So the things I'm about to say today about color theory are probably not 100% accurate, but it's good enough for you and me, for CSS people. I'm not a scientist. I'm also not Chris Lilly or Leah Veru. So it's good enough. All right, let's start with the first term. And the first term is gamut. The gamut defines the amount of colors or the range of colors. And a gamut can have a name like sRGB, for example, or display P3. What we see here is in this triangle, we see the sRGB gamut, so all the colors that exist in sRGB. And this is what we can use today. And outside this triangle, you see this gray shape, and this gray shape represents the colors that we can actually perceive. So you see that the amount of colors that we have access to is very limited. There are way more colors that we could actually see, but that's all we can use with hex or sRGB, for example. There are different gamuts. So there's the sRGB gamut, and in this illustration, it's represented by this red triangle. So this is the amount of colors that we can display in sRGB. There's another one called display P3. It's relatively new, and we can also use it today. And you can see that this triangle, the purple triangle, is a bit larger, which gives us access to even more colors. And there are other gamuts like ProPhoto or Rec 2020 that can, in theory, display even more colors. So when you talk about the amount of colors that can be displayed, the range of colors, and you talk about the gamut, and you can talk about a low range or a narrow gamut or a high range and a wide gamut. This is the first term. The second term is color spaces. A color space is an arrangement of a gamut. So gamut is the amount of colors, and when we talk about color spaces, we talk about the arrangement and also the method of accessing colors. For example, there is the RGB color space. And I know this is kind of confusing because they share the same name. So there's the sRGB gamut, which defines the amount of colors. And then we have the RGB color space, which establishes a shape. So in this case, it's a square shape. And it also defines the method for accessing colors. And you know how it works. We take a blue, a red, and a green channel, and then we mix them. And then in the end, we get a color. So this is what we are using when we define hex values or when we use the RGB function. Here's another color space, HSL, which also uses the sRGB gamut, so the same amount of colors, but just the way the arrangement and also the way of accessing the colors is different because now we use hue, saturation, and lightness. So you use the term color space to talk about the arrangement and also methods of accessing them. And you also talk about when you talk about interpolation, but we will talk about that later. Here's a demonstration of how the color keywords in CSS look like in different color spaces. So, you know, stuff like aqua and hot pink and Rebecca purple and so on. So here's how they look like in the RGB color space. And now I'm switching to HSL. And this is how they're arranged in HSL. Okay, so now we all know what a gamut is and what a color space is, and now we go back to the problem with HSL. The RGB color space is in a square shape, and when we convert it to HSL, we get a conic shape. And as long as we stay inside that shape when we pick a color, so when we define a hue, saturation, and lightness, we are fine. But if we combine values that are outside of that shape, which is absolutely possible because we can use any amount of hue and any amount of saturation and any amount of lightness with any hue, then we're out of gamuts. And this is a problem because it's unfortunately with the HSL function possible to select a color that doesn't exist. And on top of that, it's not just that we can use any combination, but also the hue wheel isn't not like this, perfect wheel as we see it here, but actually it's uneven. So there isn't 100% saturation and lightness for every hue that exists. So some hues maybe have 100% hue and lightness or can represent that, and others don't. So the solution here, or what we probably wanted here, is that the browser somehow tries to figure out which color is closest to the one that we define. So we pick a hue, saturation, and lightness. The browser is like, oh, okay, that color doesn't exist. So I'm just going to find the closest color that matches your values. But unfortunately, that's not what's happening in HSL because HSL is pretty old. And when they came up with the algorithm for HSL, they were just not able to make it performant. Like they weren't able to make the gamut mapping, that's what it's called, like finding the closest number in a performant way. So what they did is they were like, okay, we can't do that. It's too slow. So we're just going to fill up the conic shape with white at the top and black at the bottom. So it's never possible that you end up out of gamuts. Now, that's an easy mathematical transformation of RGB, but unfortunately, that's not how we perceive lightness as humans. Because the problem is, you define a certain hue and combination of saturation and lightness, you end up out of gamut, and what HSL does, it just adds white or black. But that's not how we perceive colors, and that can be a problem. Because for us, it means that the lightness component of HSL is not accurate. So HSL is fine for choosing a single color. So if you just, use a color picker and take the value as HSL is fine, but it's not suitable for using it in a design system or color system. Because the results that you get if you try to, put it in a system are not uniform and also somewhat unpredictable. Here's an example. So what you see here is a color scale, and each color that you see here has a different hue, of course, but they have the same saturation, 100%, and also the same lightness, 50%. And the problem here is there isn't a color for every hue that we use with that combination. And if you look closely, there is something wrong with this scale. And I'm sure that some of you already see it. It doesn't feel right. And it doesn't feel right because the greens are really light and the blues, for example, are really dark. And you now know the reason why. Because what we would expect is that they feel like that we perceive them in a very harmonic way. Like we perceive them in the same way. They should have the same perceived lightness. But that's not happening because, like I said, for this combination, there isn't a color. So what HSL does, for the greens, it just adds white, so they get really light. And for the some of the blues, it adds black, and then they get really dark. And I hope that you can see this here. If not, I'm going to share the slides with you, and you can check it out. I have CodePen also for you, so you can check it out on your screen. So while this scale may have consistent lightness according to the color model, it definitely feels wrong for us humans visually. And that's why we say that HSL is perceptually not uniform. And for us in CSS, this can be a big problem. Here's an example. So I have two buttons here, two actual buttons, no divs, and one says send and the other one says save. And you can see they both have the same purple, dark purple color. And for the save button, I want a variation. So I'm going to take my button component and create a variation that uses a green color. And if we take the technique that I showed you from at the very beginning that I've used with my notification component, then, we just create custom properties for H, S, and L. We reuse the saturation, we reuse the lightness, and all we do is we change the hue. So we change the 270 degrees for our second button to something that's close to green, so close to 120. I picked 90 here, and this is what we get. So we have a dark purple button and a really light green button. But all I was changing was the hue. I didn't touch the saturation. I didn't touch the lightness. So what I expected here is to get a dark green button, because if the purple is dark, then also the green should be dark. And that's not what's happening. And yeah, that makes our color systems unreliable and also a problem for accessibility because, like I said, the results are unexpected. So yeah, HSL is cool for just picking a single color, it's fine, but it's not suitable for systems. And this is where lab comes into play. Lab was defined as a, first of all, perceptually uniform color space, and it takes human perception into account. I have no idea how they do that. Like I said, I'm not a scientist, I'm just a CSS developer, and I don't care. Look, it's just good that we know, it's perceptually uniform. It takes human perception into account. I trust them. It's much better than HSL. Cool. And what's special about Lab is that unlike RGB color models, it was designed to cover the entire range of visible colors, or the entire range of colors that we can perceive. So you can see with Lab, we also have this square shape, but it's not filled completely. There's this blob inside it. And if we use another gamut with this color space, then it will just add the colors and they will always fit in this square, which is a nice thing. And the way that Lab works is there is a lightness component similar to HSL, which goes from 0% to 100%. And then we have an A-axis and a B-axis. And the A-axis is relative to the opponent's green and red. So if you use a negative value, it goes towards green. If you use a positive value, it goes towards red. And then we have the B-axis, which is relative to the opponent's blue and yellow. If you use a negative value, it goes towards blue. If you use a positive value, it goes towards yellow. And that's not just great because it's perceptually uniform, but it also uses the display P3 gamut by default, which means we can now use 50% more colors. If you remember, I showed you the triangles. The first one, the red one, was sRGB, and then we had another triangle that was slightly larger, so it didn't look like much, but actually display P3 gives us 50% more colors, which is quite a lot, especially if you compare it to the 216 that I used on my first website. There's just one thing that I don't like about Lab, because similar to RGB and hex, we are again mixing colors. Like we have this lightness component, which is fine, but you still have to mix red and green with yellow or blue, and that doesn't work. That just doesn't work for my brain. Luckily, there's LCH. Just as HSL is a easier to use cylindrical representation of RGB, LCH is an easier to use cylindrical representation of LAB. So the A and the B axis, or the A and the B channels, are replaced with chroma, which is relative saturation, and a hue angle. The lightness stays the same. The hue angle is very similar to the one in HSL, but the numbers will give you different results because HSL uses 3 additive primary colors, so red, green, and blue, and LCH uses red, yellow, green, and blue. So the numbers will give you a different result, but from the way it works, it's very similar. And you can see with LCH, of course, now we don't have a square shape, but also this cylindrical shape. And again, it's not filling up the entire shape artificially with color. It's just this blob. And if we use a gamut with a wider gamut, it will just add colors. And yeah, this is a comparison of HSL and OKLCH. And you can see that with OKLCH, this rectangle shape that we have here, it doesn't fill it up completely. And it makes sense because, like I said, it doesn't try to create colors artificially like HSL does, but it just has these gaps. And Lab does gamut mapping kind of. So what happens if you use a combination of LC and H that is out of gamuts? OKLCH will try to find the closest possible color that matches your combination. Or at least in theory, because in the spec it says the best way to do that is to use a hue preserving and lightness preserving algorithm. So one that takes the values and tries to find the closest number while still preserving the hue and lightness. Unfortunately, browsers didn't implement that. So what they're doing instead is they're using a naive gamut clipping technique that just clips RGB values. And the problem is when your color combinations are wide out of gamut, it can yield unexpected results because the lightness component is not preserved. I don't really understand why they did it. Maybe because it was easier than gamut mapping or more performance. I will give you something to read in a second, then you can find out for yourself. I just accepted that it can be problematic. Here's an example. So what you see here in the very first row is the OKLCH color 90%, 15%, and 0 degrees. And it's this light pink. And if I change the saturation or the chroma component from 15 degrees to 16 degrees, we are already out of gamut. So slightly out of gamut. I picked a color, deliberately picked a color that's on the edge. And by slightly changing it, you can see it's out of gamut, but the color stays the same. And even if I change it to 17 or 18 or 19 or 20, it gets wider out of gamut, but the color is still the same. So it works much better than HSL. It doesn't artificially add white or black or anything. The color is fine. But If I change the value to 40%, 60, 80, or 100, you can see how the color changes. And the problem is, if we get white out of gametes, then this gamete clipping technique that they are using doesn't work really well. Here's another demo that illustrates that by Miriam Suzanne. So on the left, we have two gradients here. On the left, you see what's happening in the browser right now. And in this demo, we are using a hue of 242, saturation of 50, and then the gradient shows, or this illustration shows the gradient from 100% lightness to 0% lightness. And I mean, the colors look nice, yes, but there's something wrong with this gradient because, like I said, at the very beginning, if you set lightness to 100%, it should give you white, but this gradient doesn't start at white. It starts at light blue. And if you use 0% lightness, it should stop at black, but these colors don't really get black. On the right, you see the same, how it's defined in the spec. So there's some JavaScript thing going on here that does the calculation. And you can see how this gradient is much, much better because it starts at white, it slowly gets light blue and then bluer and then dark blue and eventually it gets black. This is what we want. This is more reliable. Like I said, people are talking about that and arguing. There are a lot of comments and a lot of opinions. At some point, I just accepted that things aren't how they're supposed to be. But of course, you can join the conversation and see how it goes and read what people have to say on GitHub. Yeah, there's an issue on GitHub that Miriam raised. Okay, so if HSL is tennis, then LCH and LAB are curling. They're great, really, really nice, but they're not the perfect sport for me. And that's because there is a bug in lab and LCH. First of all, there can be a bug in a color space. Who knew? Like I said, I don't know anything about color theory, but eventually it's possible that there is a bug. And you can see this bug at the hue 200, between the hues 270 and 330, because there is a unexpected hue shift towards purple. So you can see there's this triangle, and in one corner we have white, and in the other one we have black. And then at the tip of the triangle, we have blue. And the color transitions from blue to white or from blue to black. And you can see how it turns purple, but that shouldn't be the case because we're just, transitioning blue to white and black, and it shouldn't turn purple. But that happens because there is this bug where this hue shift is happening. And this is why Björn Ottosson designed a new perceptual color space, one that's simple to use and one that's also good at predicting perceived lightness, chroma and hue, and also one that doesn't have this bug. And this is how it looks with their new color space. So you can see how the blue now nicely turns to a lighter blue and then eventually to white, or to a darker blue and then to black. And this new color space is called OKLCH. And it's called OKLCH or OKLab because it's an OK implementation of lab and an OK implementation of LCH. And here's a document where it defines the color space, and it really says it's called the OK Lab color space because it is an OK Lab color space. I just love that. That's just such a nice detail about it. Here's a demo to show you how significant the difference is. So on the left and the right, on the top, we have two color pickers. On the left, I've picked this a blue color in the range of 200, between the range of 270 and 330. And on the right, we have white. And I'm going to use the range slider and mix white and blue. And this is what we get. With lab, you can see how the color turns purple and then eventually blue. And this is really unexpected. And if I now change the color space from lab to OK lab, you can see how it turns to light blue, darker blue, and so on. So it makes a huge difference. If you're talking about using it in CSS and if you're talking about color systems and so on, so it's best to use OKLCH or OKLab instead of LCH and LAB for most of your CSS. that was a lot of theory, but knowledge that we need in order to understand how to use these things. But now let's get back to CSS. You can see we have dedicated functions for all four of them. So for LCH, LAB, OKLCH, and OKLAB. And this is how OKLCH works. We have a lightness component. You can define it using a value from 0% to 100% or 1 to 0. Then we have a chroma component with a value between 0 and 0.37, which seems like a magic number. And then we have the hue, of course, between 0 and 360 degrees. And then there's also an alpha channel that you can use by adding a slash at the end and then a value between 0 and 1. For OKLab, the lightness component is the same, and the A and the B axis, there you define a value between minus 0.4 and plus 0.4 for both. And yeah, especially the lightness and the chroma components look like magic numbers to me. So the best you can do is to use a color picker like the one we see here on oklch.com. It's built by the Evil Martians people. And this one is really cool because you can drop in a hex value. It will give you the OKLCH value. And you can also tweak it. You can see there are different range sliders you can use for each component. There is a 3D representation that smarter people than me understand. And there's also an alpha channel. And what's really interesting about those range sliders is that you can see there are gaps, there are white spaces in between. And this just tells you, okay, if you use this combination and of lightness and chroma and this hue, then you will end out of gamuts. So it tells you directly that you are out of gamuts, which is really nice. So this color picker is a very, very valuable tool. So if we go back to our button components, just so you remember, this is how we used it. We have this HSL function and we are changing the hue to 90%. If we do the same thing in LCH, so we use LC and H and we just change the H value for our button, this is what we get. And that makes so much more sense. You can see how, first of all, now the contrast ratio is fine, and it also harmonizes with the purple color. So we have the same perceived lightness and saturation. Yeah, that's nice, I would say. One thing you may have noticed is that with the LCH function or the OKLCH and OKLab and so on, we use a space-separated. We use spaces to separate the values and not commas, because there is a new, pretty new, not really new, but kind of new space-separated functional color notation. And this allows you to use spaces instead of commas for existing functions like RGB and HSL. So in line 5 and 6 here, you can see how it works without the commas. And this also allows you to use the alpha channel directly with your RGB function. So you don't need RGBA anymore. And for the new color functions like OKLCH, you can only use the space-separated syntax. So commas don't work in OKLCH and all the other new functions. So we have dedicated functions like LCH, OKLCH, and so on. And what if you want to use other color spaces? Because there are other color spaces that we could use. Like we could use, for example, sRGB linear, for example. But there isn't an sRGB linear function. This is where the color function comes into play. It allows us to use different color spaces rather than the implicit sRGB color space. And this is how it works. So you have the color function. You have 3 values that you pass. The first one is the name of the color space. So for example, sRGB linear. And then you have the values for red, green, and blue, represented by a number between 0 and 1, or by a percentage between 0% and 100%. And then optionally, you also have an alpha channel. So this is how you can use a color in a different color space, or in one that doesn't have a dedicated function. And sometimes that makes sense. And we will talk in a second about use cases for using the color function or using a color in different color spaces. The only important thing that you need to remember here is that just because you can use the Rec 2020 value here with the color function doesn't mean that you can actually also display the color. So the color may end up out of gamut. Luckily, we can use feature detection. So if you really want to make sure that colors will be displayed at all, you can say, you know what, I will start with hex values, or if you're working with a legacy code base, you can start with your good old hex values. And then you can use a media query and say, add media color gamut P3, which just basically means does the screen and the device support a white gamut, then please use OKLCH instead of hex, for example. Or you could say, add media color gamut rec 2020. So does it use a really wide color space? Then please use rec 2020. The terms P3 and rec 2020 are a bit misleading because it doesn't really have anything to do with display P3 or rec 2020. Basically, what it means is wide or really wide gamut. Okay. What's cool about having different color spaces is not just that we have access to more colors and that we can use different, ways of accessing them, but colors are arranged differently in different color spaces. We learned that at the very beginning. And this gives us different results when we create gradients. So for example, if you use our linear gradient functions that I showed at the very beginning, you can see I'm setting it to a gradient that transitions from left to right and from hot pink to aqua. And by default, it uses the sRGB or the RGB color space. We can change that by using the in keyword and the color space that we want. And we can say, you know what, give me the gradient, but in the OKLab color space. And here you can see how it looks. So at the top, we have the sRGB color space. Then we have OKLab and OKLCH. And especially OKLab is very different compared to sRGB. I hope that you can see it here. And OKLCH is kind of similar to sRGB, but the colors are a bit more vivid. So if you look closely, and I hope that you can see it, the OKLCH colors are, like I said, more intense. It's worth trying out different color spaces with your gradient. So if you use a gradient and you're like, I like it, it's fine, then, don't change anything. But it may be worth, trying it in different color spaces. And you can see how the colors in OKLCH are much more vibrant. So you may want to use OKLCH for your gradients because it will be more beautiful. But of course, it can also be that they look better in a different color space. Another cool thing about any polar color space, so one that uses hue, saturation, lightness, those channels, we have options for hue interpolation. So by default, if you define a gradient, it will take the shortest route on the hue wheel. So you see in this circle hue representation that we have two dots. And if you define a gradient from this green to this blue color, it will always take the shortest route. So it will go from green to blue. And it doesn't go from green to yellow to orange to red and then to blue. It always takes a shorter route. And now we can control that in CSS. So we have two options. We can just leave it as is, or we can define it explicitly. We can say, create a gradient to right in OKLCH and use the shorter hue or the longer hue. And this is what we get. And that's really cool because this is basically the same gradient kind of, or the same gradient definition, or these are the same colors that we're using, but the result is different just because we're using a different route. We're not going in the upper half, we're going the shorter route. In the lower half, we're going the longer route. And it gives us the same colors at the beginning and the end, but in between, it gives us a different result. And having access to different color spaces is not just useful for gradients, but also for color mixing. And some of you are thinking, color what? Yes, we can mix colors, which is also really cool, especially if you're thinking about color systems and very dynamic and flexible color systems. There is a color mix function. It accepts three values. The first one defines the color space. So you can say, I want to mix colors in the sRGB color space. And the second one is the first color. And the third one is the second color. So what this does is it mixes hot pink and aqua in the sRGB color space, and this is the result. I showed this at Beyond Tellerrand in Berlin last year, and I actually created this animation and this illustration the night before the talk, and I was really proud of it because that's a squash ball, but no one noticed, and people were very unimpressed. I hope that you were super impressed by my animation here. So the squash ball shows the color that you get by mixing hot pink and aqua in sRGB. You can also say, you know what, mix hot pink and aqua, but please give me 70% hot pink and 30% aqua. And then you get a different color that goes more towards hot pink, of course. And you can also leave 30% away and just say, you know, give me 70%, and the function will automatically choose 30% for aqua. If you use a combination of percentages that don't add up to 100%, like I'm doing here, so I'm using 13% hot pink and 12% aqua, then the rest, the remaining 70% in this case, will be applied as an alpha channel. So this is why this squash ball, or the color here, looks really dimmed. And yeah, this is how it looks like when you mix hot pink and aqua in different color spaces. And at first, I was so confused. Like, I wasn't just confused, I was annoyed. Like, I didn't expect that mixing the same two colors in different color spaces will give you so wildly different results. Like, you can say it ranges from gray to going to blue, and then something that almost looks pinkish, and then it ends up in a really dark blue, purple, bluish color. That's super confusing. And what works best with, you know, this fact that you get fundamentally different results depending on the color space you're mixing in, is that you just accept it. Just accept it and try to deal with it by accepting that this is the way it is. See it as something that's super useful and great. It's a great thing that you can mix colors in different color spaces, and it's a good feature that it will give you different results. Here's an example. Again, we're using this tool by Adam Argyle. So we're mixing hot pink and aqua, and you see how the results are very different when I switch to different color spaces here. So that's really great, but what if we're working with some legacy style sheet? Like what if someone, like a third-party style sheet, is giving us boring old hex codes, but we want to use the cool new stuff? That's where relative color syntax comes into play, because it allows us to use existing colors and modify them. Here's how it works. So you have your color function, like OKLCH, for example. And instead of defining the values, you say, you know what, give me the color from this hex code, for example. So from hash 00f, give me the lightness, chroma, and hue component. So we take the color from an existing component, and then we use the channels LC and H. And the reason why we're doing that is because we can manipulate them. So you can see here, I put the color in this example in a custom property. It's still the same. And I'm saying, you know what, give me the lightness component, give me the chroma component, but I'm going to change the hue. And this is really cool, because now we have this red color, and then we're turning it into a different color, because we can just manipulate the channels as much as we want. We can even do this, for example. We can say, you know what, give me the hex code in HSL, in the HSL color space, and I'm taking the hue, I'm taking the saturation, but I'm subtracting 10% from the lightness by using the calc function. And you can use any channel keyword at any place. You don't have to use them where they're supposed to be, like RGB, for example. You can use B at the position of R, and so on, and you know, do calculations and get crazy. The code that you see here is actually from the spec, so it works. I don't know what it does, but it works. So if we take our notification component example from earlier, where I put, you know, the hue, saturation, lightness in dedicated custom properties, and then I reuse them. This is how it can look like with relative color syntax. So I'm defining a color first, which is my info color, you know, the blues. This is my base color. And then I'm saying, you know what, I'm creating a warning color and an error color. They share the same lightness, the same chroma, and I didn't have to create custom properties for those, because using the relative color syntax, I just have directly access to these channels, and I'm only changing the hue. And in my notification, I'm using this specific color as the background color, and with the border color, I'm only changing the saturation and the lightness. It looks super complicated, but this is now really flexible and yeah, perfect for a color system. I have, okay, it's already 50 minutes or so, but I have a couple of slides left, so I'm just going to talk about them. I hope that you still have some time left. Another really cool thing is color fonts. I really like them. So if you look at this randomly picked arrangement of randomly picked letters, the letters don't look too special at first, but at the second look, you may notice that each letter has multiple colors. So it's not just one color, like usually, but actually the text here uses multiple colors. And I didn't, design that using Photoshop or Microsoft Word or something like that. That's actually a screenshot from a code pen in CSS, because there are color fonts. Cool. Okay. But what's really cool about color fonts is that some of them come with color palettes. So for this specific font, which is called Rocher, I have access to 11 different palettes, so 11 different color combinations that I can use with the font. And here's how it works. You use the add font palette values add rule. You define a name, like -- pink, for example. You define which font family you're using or which typeface. And then you define the palette you want to use. And you use a value between 0 and depending on how many palettes the font has. So 0, 1, 2, 3, and so on. And yeah, what I'm doing here is I'm defining one palette in CSS for the pink color, the green, gray, and so on. And if I want to use them, I can use the font palette property and just reference the name that I've defined earlier. That's it. So the question is now, how do I know if a color font comes with palettes and with how many palettes? That's a good question. And luckily, there's this great tool with this amazing design. It's called Wacomai Fondue. And what you do here is you pick your font, you drop it into the website, then it analyzes your font, and it gives you the number of glyphs and the size and also the format and all kinds of information. And it also shows the different palettes you can use. So this is how I know that there are 11 color palettes with 4 colors. And it also shows you the different access. So if it's a variable font, which is also really useful. So you can use one of those palettes, but what if you don't like a specific color? Well, you can just override it using the override colors property. It takes a list of 2 values or a combination of 2 values. First, you define which color you want to change, and this works by using an index starting at 0. So if you have 4 colors, you can use 0, 1, 2, and 3. And then you define the color that you want instead of the original color. So if you wanted to create a custom palette, you just use the override colors property and define a custom color for each existing color. And in this case, this gives me this. Again, a random arrangement of random letters. All right, another cool things are color schemes, or in other words, dark mode. So if you create an HTML document, by default, if you change dark mode in your operating system or by emulating in your browser, nothing happens because an HTML document without any CSS or with really limited CSS, like in my case here, is always light. We can change that by using the color scheme property and defining the preferred theme and a second one, so light and dark in this case, or you can do the same thing in HTML if you don't want to rely on CSS. And that's all it takes to give us a dark theme for our HTML document. So if you change dark mode now, you can see how it turns black. At some point, you would want to tweak colors, and you can do that by using the prefers color scheme media feature. And yeah, so by default, it's light, and you say if the color scheme is dark, then I'm going to switch the accent color or the font color, whatever. You can do that, or you can do the pretty new light dark function, which takes 2 values. The first value is the light color, and the second one is the dark. So if the operating system or the browser is in light mode, it will use the first value. If it's in dark mode, it will use the second value. So essentially, you can define 2 colors, and the browser will pick depending on the color scheme, and you don't have to use the media feature. And this is how it looks like. So by default, it's light, I switch to dark, and then it uses a different accent color on the checkbox. My friend Sarah Joy wrote an extensive article titled "Come to the Light Dark Side." written on CSS tricks. And yeah, there you can learn everything about color scheme. Okay, I'm going to go quickly through the next slides because it's almost an hour already. I'm so sorry. There is the prefers use transparency media feature, which allows us to listen to the transparency setting on an operating system. So some operating systems, macOS mostly, I guess, use transparency, or some versions of macOS use transparency a lot, and for some people this can be an issue, like the text can become harder to read. So in macOS you can say, you know what, reduce the transparency. I don't want transparency. Actually, it's easier for me if in your backgrounds of applications and so on, you use solid colors. And in CSS we can react to that. So if you have, I don't know, like a background image, and in the above this image there's a div with text, you often use like a semi-transparent color. And for people who prefer reduced transparency, you could use a solid color. Or if you have something like you see on screen here, like this glass morphism effect, you can also use a solid color instead by just listening to this setting. Then we have prefers contrast as well, which is another setting. I'll take this one with a grain of salt because it might not work as expected. My friend Kilian wrote about it in an article titled "I no longer understand prefers contrast." We have forced colors mode, which used to be the high contrast mode in Windows. Now it's a different media feature, but it basically does the same thing, where we can also tweak certain stylings for high contrast mode. Okay, that's it for me. I showed you most of the stuff that I learned. I'm pretty sure there's more, and there's more to come. But yeah, I almost spent an entire hour talking about color. So you can see there is a lot, and it's really exciting. And yeah, I even talked pretty fast, I would say. So there's a lot you can learn. And now it's your turn. Like learn that stuff and also use it and write about it and talk about it. Blog about it, talk about it at meetups. What we need now is that we don't just, read about all this exciting stuff that we have in CSS, but what we need is that we actually use it and share our experience and our knowledge so that we can learn about the best practices for these different things. For example, Roma Komarov wrote about a way to query the color scheme property or the color scheme. Leah Veru wrote about using relative color syntax to automatically compute contrasting text colors. Black magic. I don't know. I don't understand half of this article. But yeah, that's what's important. We need to try this stuff out, try to learn about it, and share our knowledge. Yeah, the last thing, if you're wondering why squash, there's absolutely no reason. One night, I woke up and I was like, it would be so cool if I would start a conference talk with the Squash Man video, and that's just what I did. And then I got a bunch of stock photos that are squash related. I don't play squash. I don't play tennis. There's no reason. Thank you so much for listening, and I hope that you learned something new. I hope that you enjoyed this talk, and I'm happy to answer questions.